Okay, so what's going to happen right now is I'm just going to start going through this first problem and just give you some thoughts. This one you might not want to store things as, but I'm gonna call this side A, and I'm going to call that side B. And if I did want to store them in there, I would just store them as A and B. And the cosine of x equals A over B. And so x equals the inverse cosine of A over B. And then, so that'll give you that missing angle, which is angle ABC right here, which is, I called it X. And then just a reminder, when you get that answer, to convert it into degrees, minutes, and seconds. And so you're going to do that answer and convert it into degrees, minutes, and seconds using that angle feature. Is everybody good with using that angle feature to change it into degrees, minutes, and seconds? Yes or no? Okay, so on the calculator to do that, what did you get for that angle, ABC? I don't even know. I don't have that in front of me. 56 degrees. Say that one more time. Okay, so at some point you had 56 point blah, 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 right? And you get that answer. Then what you do is you go, I'll just call it 56 point, whatever. You go second angle, and then number 4 is degrees, minutes, and seconds, and then it'll turn it into degrees, minutes, and seconds. So it's second angle and number 4. And that'll turn it into degrees, minutes, and seconds. You have to round it to the nearest second when you're doing that, though. Just be careful of that and make sure that you do. And then to get the distance from A to C, that's just the square root of B squared minus A squared. And again, you can just type those in using numbers as you go. And so that one should have turned out to be 132.56. So make sure that you're correctly rounding as you go through that one as well. Then the way that I would do this next one is I am just going to start using letters of the alphabet. I'm going to call that capital A. And so the way I'm going to do that is 62.25 store as alpha A. And so that side is just right in my calculator. And then I'm going to call angle EFG, which is that big angle there. I'm going to call that capital B. And the way that I'm going to do that in my calculator is I'm going to go 109 plus 49 over 60 plus 58 over 3600. Enter. And then I'm going to store that as alpha B. And if you want to write some of these things down, that's what you're going to do on the calculator when you're going through that. And then same thing with the measure of angle FEG, which is this angle right here, and I'm going to call that capital C. And then for that one, I'm going to take 47 plus 39 over 60 plus 18 over 3600, enter, and then store as alpha C. And so this is capital B, and that's capital C. I'm going to change color now because that's just getting everything in there that I need. And so the next thing I'm going to do is figure out EH. So EH is right here, and I'm just going to call that D once I get it. And to get that, do you agree I would use cosine? Yes or no? So cosine capital C equals D over A. And D is what I'm trying to figure out. So A cosine C equals D. And so I'm just going to type in A cosine C, enter, and then I'm going to store it as alpha D. And I have that answer. EH is 41.93. The next thing I have to get is FH. And so for FH, that's this length right here. I'm ABCD. I'm going to call that capital E. And for capital E, I'm just going to use the Pythagorean theorem. E equals the square root of A squared minus D squared. And so I'm going to type in square root of A squared minus D squared and enter. And then alpha, or store, excuse me, store alpha E. So I know that that's in there. And that answer, which is FH, is 46.01. I'm just going to change colors so that, I can kind of see things a little bit easier. The next thing I need is segment FG. And to get that, I'm going to figure out a letter F, which is going to be just this little angle right there. And I'm going to call that little angle F, and that is going to be 90, capital B minus 90 and plus C. And so I'm going to call that, this is the measure of angle GFH, and I'm going to call it capital F. And so I don't know if I can quite get that F in there. There we go. And to figure out what that is, it's angle B minus the 90, and then let me say it this way, F is equal to B minus 90 minus C. And so that 90 minus C is that little piece right there. And so F is equal to B minus 90 plus C. And I can just type that in, B minus 90 plus C, enter, and then store as alpha F. And then I'll have that little angle right there. I wasn't asked for that angle, but it's going to help me get something as I go. And then I want FG. So now in this triangle, I'll maybe trace it in yellow. I know that's FH, which I called capital E, and I know this angle that's in black there, which is an angle F. So I'll just put a little arrow there. That's capital F. And so now I want to get FG, which is right here. And alphabetically, I'm up to the letter G. And so I'm going to call that G. I'm going to use this angle. I'm going to use that side and this side. So I'm going to use cosine again. So I'm going to say the cosine of F is equal to E over G. And it's G that I want to find. So G is equal to E divided by cosine F. And so on my calculator, I'm doing E divided by cosine F, enter. and then I'm going to store that as alpha G. And when I get that answer, it is FG, which is 120.17. And so that gives me that piece right there. And then I'm going to need this GH, and so I'll use a different color for that. Whoops. And so GH, I'm just going to use the Pythagorean theorem for that. I'm going to call that piece H, although I might not need to name it. And so that is going to be H, and it's going to be the square root of G squared minus B squared. Oh, I'm sorry. Yes, it is E. Thank you. The square root of G squared minus E squared, because the B was that big angle. Thank you. And when you get that one, it is 111.01. And then you need angle EGF. And then if you look at angle EGF, that is just of the big triangle. So I'll just do this. Angle EGF is this angle right here. You know this angle is B, and you know this angle is C. So really, I would go 180 minus B minus C. Enter. And then I don't have to store it. It's my last answer, but I would do what? Because I have to change it into what? Degrees, minutes, and seconds. So what are the buttons to push for that? Second angle, oh, right angle, and then number 4, and that'll change it to degrees, minutes, and seconds. And that one turns out to be 22 degrees, 30 minutes, and 44 seconds. Then for this page, page 2, it's problem 2 because page 1 is problem 1A and B as you look at it. So we know that right away, those are just the answers. We know that right away we're going to draw in that other diagonal. And so I'll just draw that right in right away. I'm calling BC capital A, so 363.56 is capital A, that distance right there. And I'm calling CD capital B, so 191.18. I'm going to store as capital B. And then the measure of angle BAD, I'm going to call that angle C. And so to get that one, I'm going to go 76 plus 47 over 60 plus 50 over 3600. Enter, and then store as alpha C. And so I'll have those 3 in there right away. And so then I'm just going to start finding things. I'm not that concerned about what answers I'm being asked for because I know there are only certain things that I can kind of figure out. And so the first thing I'm going to find is this angle D. And since that adds up to 360, there's a 90 and a 90, that's 180. So C and D together add up to 180. So D is just going to equal 180 minus C. And so I'm going to do 180 minus C, enter, and then store as alpha D. So I have all of the angles there. Then I'm going to call E this length right here. I'm going to call that E. I'm going to use the law of cosines. And so I've got the A, B, and D, and I'm going to find that E. So E is equal to the big square root of law of cosines. It'll be A squared plus B squared minus 2AB cosine, what? D. And so when I type all that in, I'm going to enter and save it as alpha E. And then maybe I'll change to another color. Then I think once I get that, I can go to the law of sines, and I'm going to call this angle right here, angle F. And when I use the law of sines to do that, I'm going to say the sine of angle D over side E. So the sine of capital D over side E is equal to the sine of capital F over capital A, those stored things. So then if I want to get F, it's going to be the inverse sine of A sine D all over capital E. And make sure your calculator is in degrees as you go through that, just to kind of remind us of that. And then personally, I'm going to find this little angle right here. Next, I'm going to call that angle G. And what's true about F and G? They just add to be what? 90. And so I'm going to say G is equal to 90 minus F. And I can either store that in as G, or when I need to use that angle, just call it 90 minus F. It doesn't matter as I go through that. And then H is the next angle I'm going to get. That's going to be this little angle right here, so that I'll have all three angles of that one. And these three angles, C, G, and H, all add up to 180, correct? Yes? And so to get H, I'm going to do it as H minus G minus C. Is that okay? Because it would be minus the sum. So I'm going to say H equals 180 minus C minus G. And then I'll store that in as H. So I have that angle. And then I need to find three lengths. Excuse me. So the first thing that I'm going to find, and once I find these lengths, I don't really, well, I can store them as I go. So I'm going to call this length I, which is AD. Oh, which isn't the first one. That's all right. That's the one I picked to do, is I. And for that one, I can use the law of sines because I have that big E and I have the big C. So I'm going to take E over the sine of big C is equal to I over sine H. And so it's I that I want. I is going to equal E sine H over sine C. And that's a length that I need. And I don't have any of my the answers actually written on here, but that should be 839.38 when you get that far. Then the next thing I'm going to find is AB. And at this point, I don't have to keep storing things because I just need these single answers. But if I want to, I sure can. And so next, I'm going to find AB. I'll just maybe scribble along that. And I'll call it J. And then to get that, I'm going to take E over sine C is equal to J over sine G. Do I have a? I'm just, oh, I looked at the wrong key. My bad. Thank you. Let me back up to this. This one, I looked at the wrong key. That's the other one. 418.28, is that what you got? Okay, my apologies. So that that was letter, is that letter I? Okay, that's capital I. So I have an error there. And then capital J should be E sine G over sine C. And J should be 281. Is that better? 281.66. And that's J. And then the last thing I need is AC. And now AC is just that hypotenuse of this right triangle. And so to find AC, it's just going to be the square root of what squared plus what squared? I squared plus B squared. And that maybe gives 459.90 for that one. And then the next problem on this one looks like this. And I'm just going to give you some hints on that one. You have the answers to that. And just so that you kind of are thinking about things that you might need to figure out. And what one thing you might want to do is find a perpendicular right there, just to kind of let you know. And also, that's a straight line, believe it or not, as you go through there. And then from this C, if you make a perpendicular right there as well. And then if you, and this one's a little trickier, if you draw in a length from E that, I don't know if I can say that without, oh, well, here's another thing you would maybe draw in. Draw in a perpendicular there. And I just want to kind of say all that so that it kind of gives you some ideas of what you could be doing there. And so, yeah. So that's everything I want to look at in that problem. And then you're just kind of on your own to be looking at some of those a little bit more in detail. And I'll put some things on the YOLA site to kind of look at them. And then I'm going to continue on with notes for 6-4 for these last couple of minutes of class here as we go. Oh, and I don't know where I left off on 6-4. I know. Um, 6-4, where did I leave off? And had we done a lot of notes? Oh, there, I can't see. Oh, there we are. Oh, yes. So the angle between two vectors is where we are. And so we're just going to kind of use every minute here. Boy, we are not very far on these 6-4 notes. So we will continue on with the angle between two vectors. And this is what you need to write down. So if you have two vectors, and you might want to sketch a picture like this. So you've got vector u and vector v, and you need to find the angle between those two vectors. If theta is the angle between the two non-zero vectors, vector u and vector v, then, and I'll just rewrite this, the cosine of theta is u dot v divided by the magnitude of u times the magnitude of v. And so do you remember the dot product from last week? It's the product of kind of the x's, I'll say it that way, plus, and then the product of the y's. So I'm pretty sure we can get through this problem without any trouble. Perfect. So the little thing you have to remember is the dot. You have to find 3 parts. So I even will tell you that I believe when we test on this, I ask you to find all of the parts as well. And so that is something that you're going to want to know. And so the other thing you want to kind of also be aware of is that sometimes we're looking at the angle, the angle between those, and so I'm right now not finding my personal notes for 6-4. Let's see if I have something here. 6. Okay, so do you have that written down? And you're ready to go. Okay, so here's our next problem, and that is to find the angle theta. So this is 3a. If vector u is in component form 4, 3, and vector v in component form is 3, 5. So the first thing I'm going to have you do is just find u dot v. And then to find the magnitude of u and the magnitude of v. And my u didn't Didn't print that well. But take a minute and just figure those out. Okay, what's u dot v? How do you get it?
4 times 3 plus 3 times 5.
And so what is that?
12 plus 15 plus 1.
And what is the magnitude of u? Uh, oh, just the plain old magnitude. Uh, 4 squared plus 3 squared.
Wow.
It's the distance, so it's the Pythagorean theorem. And what is that? 5. Do you agree? That one works out to be 5. This one, what do you have to do? Same thing. 3 square root of 3 squared plus 5 squared. What is that? The square root of 34. So now I'm going to, and I'm going to also remind you that sometimes it's going to give you a reference angle. Here we have this angle between those two, and it's plotted on there so we can kind of see that it's an acute angle. It's not going to be a problem. So the cosine of theta is u dot v over the magnitude of u times the magnitude of v. And so that is 27 over 5 times the square root of 34. Now, do we have to rationalize that denominator and do all that? Do we? I wouldn't, but you sure can. But I just am using this to find theta, right? So I don't even have to simplify it, or I don't really care what that is. So theta is going to be the inverse cosine of 27 divided by 5 square root of 34. And the book authors gave this one in radians, so just keep in mind we want to be able to work in either.
Why? Why don't we do it in radians if it's in degrees?
Who said it was degrees?
Right there it says degrees.
Oh, not always. So in radians, and let's see, I will either on a test either indicate which I want or accept either. And this one is radians 0.3869 radians. What?
Weird message.
When you go 27 divided by on a calculator, then you have to put the 5 square root of 34 in parentheses. So it divides by that whole thing. Just letting you know.
Oh, wow. I still need help. Oh, this is going downhill. Try it back up.
Did you get it to work?
138.
Okay, got it? Okay, so for our time elements, sometimes I'm just going to show you answers. And so this is 3b. Just look at it. U is 2, 1. It's the exact same problem. So we're not going to do it. I'm just going to show it to you. And so if you want to try it in the notes, the empty slide is there. And then the next slide will have this work on it. So You find the dot product, you find the magnitude of each of those, and then find the inverse cosine. As you know, typing in is kind of an important thing to do. I do want to go through that problem next, and so add problem here. And then tomorrow, okay, so listen, if I can be ready tomorrow when the bell rings, I'm going to start notes, and when the bell rings, I'm going to stop notes, just to let you know. And so that's where we'll be.